Hello students, Jai Hind, Vande Mataram. Once again welcome back to the class of Ravi sir, the easiest and finest way to learn the concepts of mathematics from standard 9 to 12th. Students, in our today video lesson of standard 9th maths chapter 6, we are going to learn about lines and angles. In this video lesson we will include introduction and full concept of this chapter. Students, if you are new to this channel, just subscribe and don't forget to hit the bell icon. So first of all, we will learn about line. What is line? Collection of points can be extended in both direction. What is collection of points which can be extended in both the direction are known as or is known as lines. Suppose these are the collection of points. Now these points making a line, so these lines can be extended in the both the direction, right students? So this is what exact definition of line. Understood? Next is a line segment. A line having two endpoints. A line having two endpoints are known as line segment. A line with two endpoints are known as line segment. Here A and B, these can't be extended in both directions. P, Q is a line segment, right students? Then after ray, what is ray? A line which can be extended in only one direction, or a line which having one endpoint. A part of line with one endpoint is known as ray. Here A is endpoint, B can be extended in other direction, P is endpoint, Q extended in another direction, right students? So ray can be extended in only one direction. Now collinear points. What are collinear points? Three or more points lies on a same line, right, are known as collinear points. So the points 3 are three or more points lying on the same line, lines are known as collinear points. Here this is a point A, B and C, D. These points are lies on line L. So A, B, C, D are collinear points. Understood students? Now non-collinear points. Three or more points do not lying in the same line are known as non-collinear points. Three or more points do not lie on the same line are known as non-collinear points. Suppose a point A, B is over here, C is somewhere here, and D is here. Suppose we are joining AC, so A, B and D are not lies on line AC, so that's why A, B, C, D are non-collinear points, because these points are not lies on the same line, right students? Now moving to the next point, angles. What is angles? Inclination of two rays, inclination between two straight line, right? Otherwise two rays, you can say that collection of two ray with common vertex. This is also angles. So A, B is a ray and AC is also a ray. Here theta is known as angle. A is known as vertex because in ray AB and in ray AC, A is a common point, so common point is always known as vertex, and these rays are which are making angles are known as arms. So what are arms? Ray AB and ray AC are what? Arms. So arms are what? Rays making an angle are known as arms, and vertex is what? Common point of two rays, right, which do not lies on the straight line is known as vertex. Common point of two rays which do not lies on the straight line. Acute angle, angle having measure less than 90 degree is known as acute angle. Suppose an angle over here considering BAC. If theta is less than 90 degree, theta is less than 90 or lies between 0 to 90 degree, so this is what acute angle, right angle. An angle having measure 90 degree, an angle having measure 90 degree. Suppose here theta is what, 90 degree, this angle is known as right angle. Obtuse angle, an angle having measure more than 90 degree but less than 180 degree. Suppose here is been the line rays PQR are making an angle, so obtuse angle is always greater than 90 but less than 180 degree, right student? Okay, next is straight line angle, an angle having measure exact 180 degree, right? Suppose here is a ray AC and AB are lies on a straight line, so its angle is 180 degree. This angle is known as straight line angle. Reflex angle, an angle having measure greater than 180 but less than 360 is known as what? Reflex angle. Angle having measure greater than 180 but less than 360 degree, that angle is known as reflex angle. So here angle BABC is what? Reflex angle. Next is intersecting line. Two lines are said to be intersecting if they have one common point. So two line L and M is said to be intersecting if they have one common point, right? So here suppose L and M are intersecting at point O. O is a common in both the line, right? Next is parallel line. A line is said to be parallel line if they do not having any common point, right? Then those lines are said to be parallel line, right students? So here L and M are said to be parallel line if they do not have any common point, right? So L and here is M, these two lines are parallel lines. Okay, next we are discussing about theorem. So in theorem, if two lines intersect each other, right, then vertically opposite angles are always equal. If two lines intersect each other, then vertically opposite angles are equal, right? Suppose here is been the line, other line, airline AB and C and D intersecting at O, right? So these are the vertically opposite angles. So angle AOD and angle COB are vertically opposite angle, right? And angle AOC and BOD are vertically opposite. Let's annote these things by 1. Here is 2, here is 3 and here is 4. It means 1 and 3 will be equal vertically opposite angle and 2 and 4 will be equal because vertically opposite angle. Now theorem 2. In theorem 2, if a transversal means a line which intersect two parallel line. A transverse intersect two parallel lines, right? If a transverse intersect two parallel line, each pair of alternate angle, each pair of interior alternate angle, each pair of interior alternate angle are always equal, right? Suppose here is two parallel line A and B. Parallel lines are A and B, C, D. and transverse line, suppose this is transverse line P Q R S. Suppose here is been they are this line is intersecting this line, so AB parallel to CD, right? Because these two lines are parallel, means they are not intersecting, right students? So here this transverse line intersect the parallel line at what, Q, and here is R and S, means transverse line is PS, right students? So here you can see that this portion means angle BQR is equal to angle CRQ. So these are interior alternate angle, right students? So in this symbol you can remind about interior alternate angle, right students? Now moving to theorem number 3. If transversal intersect, this is converse of theorem 2. If transverse intersect two lines such that a point of alternate interior angles, right, is equal, then those lines are parallel. Then those lines are parallel, right students? This theorem is converge of theorem number 2. Here is been two parallel line A and B, C and D, and this time we have to consider interior angles are equal. Means which angles are equal? Angle BQR and angle CRQ are equal. So AB will be parallel to CD, right students? Is it clear? This theorem is converse, means opposite of theorem number 2. Okay, now theorem number 4. In this theorem, if a transversal intersect two parallel lines in the, then each pair of interior angles on the same sides, each pair of interior angle on same side of the transversal are supplementary. Is supplementary, means sum of the angle will be 180, right students? So here let us see two parallel lines AB and CD, two parallel lines A, B, and here is C and D. Transversal P, here is Q, here is R, and here is S, right? So here interior angles of same side means angle PQR, angle AQR plus angle CRQ, right? Means here it is already given that AB parallel to CD, so angle AQR plus angle CRQ, right? So these two angles, sum of these two angles are 180 degree. So 180 degree, right students? So these two angles are supplementary. Supplementary means sum of these two angles will be 180 degree. In this symbol you can remind about angle on the same sides of interior. Next, theorem number 5. This will be converse of theorem number 4. If transverse intersect two parallel lines such that two lines, not parallel lines, such that the pair of interior angles are supplementary, are same sides of the transversal is supplementary. In that case both the lines will be parallel. It means this is just opposite to theorem number 4, right? So but we have to prove that those two lines will be parallel. Here A and B, we don't know AB are parallel, but a transverse P, here is Q, here is R and S. Here it is been given that AQR and CRQ is 180. AQR plus CRQ is 180. That's why AB parallel to CD. Right, students? This much you will have to prove, because here AQR and CRQ is supplementary. That's why AB parallel to CD. Okay, student. Now moving to the next theorem 6. Lines which are parallel to same lines are parallel to each other. Right, students? Here we will discussing about three lines. Suppose AB is parallel to CD and CD is parallel to what? EF. In that case, AB parallel to EF means AB parallel to CD and CD parallel to EF. That's why EF will be parallel to AB. Right, students? Is it clear? If two lines are parallel and two lines is parallel, second line is parallel to third line, in that case first and third line will be parallel. Now the next theorem, theorem number 7. Sum of all interior angles of a triangle is 180. Sum of all interior angles of a triangle is 180. Suppose here is been triangle ABC and the interior angle ABC, A plus B plus C is equal to 180. Understood, students? Sum of all interior angles of a triangle is what? 180 degree. Now let us discuss about axioms. If a ray stands on a line, then the sum of two adjacent angle is supplementary. Sum of two adjacent angle formed so is supplementary, means 180 degree. If a ray stand on a line, then sum of adjacent angle is 180. Here is ray OC stand on AB, so angle AOC and angle COB will be what? 180. So AOC plus BOC is equal to 180 degree. Now moving to axioms 2. In axioms 2, if sum of adjacent angle is 180 degree, then the non-common arms of angle form a line. Right, students? So this is just opposite to the axioms 1. Here is straight line AB and ray OC on stand on AB. If AOC plus BOC is 180 degree, in that case what we can say that AB is a straight line. Understood, student? Now axioms 3. In axioms 3, if a transversal intersect two parallel lines, if a transversal intersect two parallel lines, then each pair of corresponding angles are equal. Each corresponding angle is equal. So students, let us consider here is two parallel lines. This is line AB and this is CD. AB and here is CD, right? And consider here is been the transversal. This is P intersecting at Q, at R and S, right? So corresponding lines means angle AQR and angle CRS, angle AQR, right, and angle CRS are corresponding angles. So we can write angle AQR. No, AB is parallel to CD. First of all, writing AB is parallel to CD. So AQR is equal to CRS. CRS. So these are what? Corresponding angle. Right, student? Is it clear about corresponding angles? Okay. Axiom 4. If a transversal intersect two lines such that a pair of corresponding angles are equal, then those two lines will be parallel. This axiom is just converse of axiom 3. Right, students? This is converse of axiom 3. So here is been line A, B and C D, right? Transverse PS intersecting at Q and R. Here is been given that AQR is equal to CRS. Right, student? Angle AQR is equal to CRS. So AB will be parallel to what? CD. Okay, students, here we are completing today video lesson. I hope you have understood about the concept of this chapter. For more video lesson of this chapter, keep watching your channel Ravisirjee. Thank you, students, once again for watching this video till the end.